Okay. So, just making sure this is working. Today we're going to translate and classify conic sections. And our objective is to graph translated circles, parabolas, ellipses, and hyperbolas. So everything's going to come together today. We've been working with hyperbolas, circles, parabolas, ellipses, those kind of things in standard form where they are all at the origin. Today we're going to work on graphing and interpreting graphs and putting them into something that's not a standard form, where there's a translation, or they're moving that, basically that center point, if you want to think of it. And we've been working, these things are called conic sections, and the reason they are called conic sections is because if you have a double-naped cone, and you take some plane and you intersect a cone, you will make these figures. So if you intersect it kind of diagonally, you'll make a parabola. If you intersect it horizontally, you'll make a circle on these cones. You can also make an ellipse if you don't go all the way down to the bottom of the cone, or if you have a vertical plane and you intersect all the way through, it's going to be a hyperbola. So that's kind of why they're called conic sections. But we're going to write the standard form of these equations, and they're going to be almost the exact same, except there's going to be one small key difference. There's going to be the point HK, so we're going to have H and K values, and that's the vertex of the parabola, and it's the center of the other conics for this, for the circle and the ellipse and the hyperbola. It's kind of that center point. So I'm going to rewrite these equations, and you should find that they look incredibly similar to the equations we've seen before. Okay, so you should notice that these equations are basically the same exact equations we've seen before, except wherever we have an x, we're going to subtract that h value from the center point. Where we have a y, we're going to subtract that k value, no matter what. So if we have an x, we're going to have x minus h. If we have a y, we're instead going to have y minus k. And that's going to be the same thing for each of these equations. So just a quick review. Remember, r in the circle stands for the radius. Here, when we have a parabola, we know it's going to open like this. If it's y minus k squared on the left side, it's going to open up or down if it's x minus h squared, so on and so forth. An ellipse, remember, our a value is going to dictate whichever one is, whether we have a horizontally aligned ellipse or whether we have a vertically aligned ellipse. It's going to be dictated by, well, whichever one has that a value, the greater value. So if that greater value is underneath, the x minus h squared, we know that the ellipse is going to be, centered with a horizontal major axis. And then we know that this one's going to be centered with a vertical major axis when that a squared is under the y. And in hyperbolas, it's dictated by whichever one's positive. So if our x minus h squared is out front and then we're subtracting y minus k squared, we know that for a hyperbola, that's going to be a horizontal transverse axis. And if our y minus k squared is the positive one, then we know it's going to have a vertical transverse axis. Okay, and that just means, well, if this is a horizontal transverse axis, it's going to have this line here, and it's going to, it's going to open up like this, something like that. And if it has a vertical transverse axis, it's going to connect the two vertices, and technically it could extend to the foci. It's going to look something like this. So if you want to draw sketches next to these to kind of signify what they're going to look like, that might not be a bad idea. So actually, let's kind of do that. This one's going to look like this. This one's going to look like this. This parabola is going to look like this. Or a parabola could look like this or this. And then an ellipse, well, when we have it in this form, and the a value is greater, we know it's going to be something like this. And when it's like this, it's going to be something like that. So if you want to draw those sketches next to them, just so you can kind of know what they're going to look like, that's certainly a fine thing to do. So let's move on to our first example here. We want to graph the equation of the translated circle. So in these problems, you basically want to identify where your center is going to be. Find your h and your k value. And keep in mind that you're subtracting your h value. So this 2 right here is our h value. A lot of people think that it should be -2, but remember that you're doing x minus that h value and y minus that k value. So unless it's plus, you should know it's just going to be that value. So since it's -2, our value is going to be 2 for h and our value for k. Well, what do I have to do if this is supposed to be y minus some value equals y plus 3? Well, it should be y minus -3 squared. So basically, if it's positive, it's going to be the opposite, if you want to keep in mind. That's going to be our new starting point of this circle. So we go 1, 2, 1, 2, 3. Here's our center. And the radius is still going to be the same. We know r squared equals 9, which means r equals 3. Since it has to be positive, our radius is 3, 1, 2, 3. And then just make your circle. So really, circles aren't too much different. They're pretty much the same. Really, you just got to start by finding your new center point of that circle. Start by finding your new center point. And I guess that's kind of going to be true for all of them, but start by finding the center point. Okay. To graph an equation of a translated hyperbola, you're still going to want to find that h and that k value. Okay, now keep in mind that h is aligned with the x and the k is aligned with the y. So our h value is going to be given from here, this x plus 1, which means our h value is -1, and our k value is going to be 3, positive 3. So this is going to be since it's a hyperbola, it's still going to be our center point. The only time where it's not our quote-unquote center point is when we have a parabola. Otherwise, it's going to be the center for everything. So here we have -1, and I'm going to do this in black. -1, 1, 2, 3. This is the center of our hyperbola. Now, we need to graph other things for this hyperbola. We need to find our vertex for each part. We need to find our focus, and if we wanted to, we could find that b value. But we have our center, and we know that the vertex is determined by, well, this value here, this a value. Well, what is, here, let me try and use, I thought I had the green up here somewhere. We know that, well, in hyperbolas, the a value is always under the front term, the positive one. We know a squared equals 4, which means a equals 2. Now, typically, we would say that our point would be 0 and then plus or minus a, right? If it's going to have a vertical transverse axis, but technically it's not going to be, we'll still have a vertical transverse axis, but it's not going to be on the y-axis. It's going to be aligned with this point, -1 and 3. So really we're starting here, and then we're going to have to go up we're going to have to go up 2 values. Remember that a represents a distance, so what we're saying here is start at center, go distance of 2. And that's going to be the true whether we had x out front or y out front. We just go a distance of 2. So 1, 2, this is going to be one focus point, go down to 1, 2. This is another vertex, I should say, not a focus. Now, if we wanted to find our focus, we know, well, a is going to be 2, b is going to equal 3, since 3 squared is 9, and we don't know what c is. C equals question mark. So we know, well, what's the, had a stroke there. What is the equation that relates these? We know c squared is going to equal a squared plus b squared for hyperbolas, a squared plus b squared. So we know that, just do this all in black, c is going to be the square root of 4 plus 9. So c is going to be the square root of 13. And we know that the square root of 13 is between the square root of 14 and the square root of 9, so it's somewhere between 3 and 4. C is going to be about 3.6. And keep in mind that that is also the distance from the center. So the focus's distance from center is 3.6. So we go up 1, 2, 3 about here, and we go down from the center 1, 2, 3 about right there. Okay. Now we could certainly label our points here, and in fact we should probably do so. This is going to be a point of, well, -1, everything's on this vertical line, -1, -1, and then this one is 3 more, or 3.6 more than 3, so 6.6. This one would be -1, and then 3 minus 3.6 is going to leave you with just 6/10. Oops. Our vertices are going to lie at, well, 2 below that would be -1, 1. This one's going to be -1, and then 3, 4, 5. And then our center is, of course, at -1 and 3. Okay, so we've basically labeled all the things we need. We didn't label our B value. If we wanted to, we certainly could. B is 3, so it's going to be a distance of 3 units on each side. 1, 2, 3. 1, 2, 3. And then we can kind of make our rectangle. And then from there, make our asymptotes. Remember that this rectangle we're constructing goes through the vertice and that B value. I guess the distance of B value. And our vertice, let's zoom in here, or not our vertice, our asymptotes kind of go diagonally through that. So here's our asymptotes, and then we can just draw our hyperbola. It's going to look something. That's not the color I want. There we are. It's going to look something like this. And again, it doesn't say to, but if it did, make sure you identify your focus, your vertice, things of that nature. So that's how you do a translated hyperbola. In all of these problems, find your center and work from there like you had previously. Okay, in example 3, we want to write an equation of a translated parabola. We want to write an equation of a translated parabola. So we want to write an equation of the parabola whose vertex is at -2, 3, and whose focus is at -4, 3. Well, let's start by just writing what is the equation of a parabola. And keep in mind they can open left or right. Normally the standard form would be, well, y squared equals 4px or x squared equals 4py, but we have a translated circle, so we're going to have some center point h. Okay, or some, and since it's a parabola, we don't have, in a hyperbola we basically have 2 parabolas. In a parabola, our center point is just going to be that focus. So since we know that focus is -4, that center point vertex here. That vertex is -2, 3, 1, 2, 1, 2, 3. And we have a focus, at -4, 3. And I believe we've been doing focuses in red, so let's keep to that. -2, 3, 4, 3. Here's our focus. We know our parabola is going to look, this is just a rough sketch, it's going to look something like this. Since that's our focus, it has to open like that. Okay, well, we want to write the equation of this, knowing that we have this vertex, -2, 3, and a focus, -4, 3. So let's just write, well, we have one of 2 options. It's either going to be y minus k squared equals 4 times p times x minus h, or it's going to be x minus h squared equals 4 times p times y minus k. And which one is it going to be? Well, keep in mind, if you are a y squared or whatever, y minus k squared is isolated, it should open left and right. If it's your x squared is isolated, it should open up and down. So we know that this equation should be this one. Since it opens left and right, this is the one we want. And then we just fill in some values to start with. We fill in some values. Okay, well, What is our h value? What is our h value? This is technically h and a k. -2, 3, since this is our vertex of the parabola, you can think of it as your center point for the parabola as well. Our h value is going to be -2, our k value is going to be 3. So our equation we can write is y minus that k value, which is 3, squared equals 4 times p times x minus h. So x minus that h value. And our h value is -2. So we're doing x minus -2, which is the same as x plus 2. And then we are basically done, but we need to find, well, what is our p value going to be? And you have to keep in mind that p is going to be the distance between that focus and that directrix, right? Or I guess not the focus and the directrix. It's the distance between this center point and that focus, or the distance between the center point and that directrix. Well, we have the focus, and its distance is what from the center? Okay, I'm going to make a mistake here, and in the top right corner I'm going to write or, and then I'm going to show you how to find the p-value, but that only applies for the standard form of the equation. Ignore that. Finding the p-value is essentially, what you want to know is it's just finding the distance from that center point to the focus. And in that case, the distance is 2, so it could be plus or minus 2. Since it's to the left, we'll eventually conclude that it should be -2. We have this equation, and since our focus is to the left, if you want to think like this is 0, if we were starting at 0, like if we were using a standard form of our equation and we had p here, we know that since it's to the left, if this was our p, like if we were graphing in standard form, since it's to the left, we would know that the p-value would have to be less than 0, meaning it would have to be negative. So while there is a distance of 2, our p-value could be plus or minus 2, but since p, or I guess you should say since the focus is to the left, more importantly, we know that p should be less than 0, which implies that p equals -2. Okay, so you find that distance, and then you have to think, is it going to be negative or positive? You have to think, is it going to be negative or positive? If it is to the right, it would have to be positive. All right. So our equation we can write here is going to be y minus k squared equals, put that in parentheses, 4 times p, 4 times -2 times x minus h, and let's just clean that up a little bit, where our final equation is going to be y minus k squared equals 4 times -2 is -8, and then we have x minus h. That is, I don't like that. That's our final answer. Maybe I'll just highlight it. That's what we're looking for here. Okay, so in these problems, really it's going to start by finding the center, or if you're trying to write an equation, you're still going to kind of want to find that center when possible. So we'll move to another example of writing an equation of a translated thing. You want to write an equation of a translated ellipse with foci at 1, 2, and 7, 2, and covertices at 4, 0, and 4, 4. So write an equation of a translated ellipse. Well, let's just go ahead and graph these things. If we have foci at 1, 2, and 7, 2, and covertices at 4, 0, and 4, 4, let's label those things. So we have covertice at 1, 2, 3, 4, 0 right here, and 4, 1, 2, 3 up here. So these are our covertices, which means we already know that our ellipse isn't going to look like this. It should look something like this, right? It's going to be horizontally oriented since we have these covertices here. And we have foci. We have foci at 1, 2. Okay, now do not connect these dots because these are not the vertices These are the foci, which means the vertices are going to exist a little bit more this way and a little bit more this way. Here's what we need to do. We need to find those vertices, because that will give us our A value. We need to find the center as well. So there's a couple things we need to do. Let's first start by determining, well, we have an ellipse. What's our equation going to be? And since these are our co-vertices, we know that there's going to be a major axis that is horizontal. Since our co-vertice, I guess let's just conclude. We know the foci always lie on the major axis. And you would have to make a horizontal line there. So that's really the tell. Since the focus lies, or I guess you would know that the co-vertices don't lie on the major axis, so it would also have to be horizontal. So since the foci lie on the major axis, it is a horizontal ellipse, which means we're going to want the equation x minus h squared over a squared plus y minus k squared over b squared is going to equal 1. Okay, so we got to find our center, we got to find our A, we got to find our B. Okay, now we haven't specifically done this before, but I am pretty confident we can find our center. We know that these co-vertices are the very edge of this ellipse, and we know that the center of the ellipse is going to be where? And you can use these 2 points. If we had our vertices, like if they were over here, I'm just going to draw them for now. You could use those as well. But we know that the centers, well, it's going to be the center of the ellipse. If these are the very edges of our ellipse, well, we know that our center has to be the halfway point. So we can use the midpoint formula. And you might not have to do it in this instance, but I'd recommend you practice it because you're not always going to have nice integers. So we can use the midpoint formula to find that center. And that's going to be, well, remember the average of our x values over the average of our y values. So 4 plus 4 divided by 2, that's our x value, and then 4 plus 0 divided by 2 will be our y value. Well, 4 plus 4 is 8 divided by 2. That's just going to be 4. You can already tell that just by looking. It's going to lie still on that same vertical line. So this is going to be 4. This is going to be 4 plus 0 is 4 divided by 2 is 2. This is our center point. Well, how does that help us? That gives us our h. That gives us our k. So we can now write, well, sort of further right. We have x minus our k value of 4 squared plus y minus our k value, which is going to be 2 squared. It's going to be equal to 1. This is over b over a. We need to find our a. We need to find our b. We know that your b value, we know our b value is always going to be gotta look at my notes here. Where are we? Okay, sorry about that. My OneNote closed itself for some reason. We know that these A and these B's and these C values always represent that distance from that center point. So, well, what is our distance from that center point going to be? Well, for our co-vertices, that's our B value. I guess maybe I should write this. Let's use, I don't know, rainbow. For A, B, C, they are distances from the center. They're always going to be the distances from the center. So our B is going to be related to our co-vertice. So B is distance of co-vertice. Now you might have to use the distance formula to find them if you have hard numbers, or you can just count. In this case, our distance is going to be 2. So we know B equals 2. The distance of our foci, and I guess maybe I should label these. This is 1, 2, this is 7, 2. Well, that's just going to be an x distance of 1, 2, 3. 1, 2, 3 in each direction. That means C is going to be 3. And we have to think, well, what is the equation that relates A, B, and C when we have an ellipse? And we know that that is going to be C squared is going to equal A squared minus B squared. Oh, goodness. This is driving me nuts. A squared minus B squared. Okay, or if you wanted to isolate A, you could add B. That would mean A squared equals C squared plus B squared. Or A is going to equal the square root of plug in our C, plug in our B, 3 squared plus B squared, which is 2. A is going to equal the square root of, well, 3 squared is 9, 2 squared is 4, 9 plus 4, square root of 13, again, which would be about, what was that? I think we did that earlier. I'll just look before. The square root of 13 is about 3.6. So if you wanted to label this, label your A value. We'll do that in green. It's going to be a distance of 3.6. So 1, 2, 3.6, which is going to be 1, 2, 3.6. And then we could connect our dots. This is going to be a value of, well, 0.4, comma 2. This is going to be a distance of, well, 0.6 more, so 7.6. 1, 2, 3, yeah, 7.6, comma 2. And we could connect our lines if we wanted to, but our goal was just to write this equation. That was a terrible ellipse. Let's try that again. One more time. Last try. Better. All right. So let's plug in our A values, plug in our B values. Our final equation is going to be x minus 4 squared over A squared, which is, well, the square root of 13 squared is going to be 13 plus y minus 2 squared over B squared, and B is 2, so that's going to be 2 squared, which is 4, and that equals 1. That is our final answer. This is what we're looking for. Okay, so that one's pretty involved. Once again, you kind of want to find your center, find those, when you're trying to write an equation, find the center, find those distances, those A's and those B values. If you're working with a parabola, find your P. That's all we are going to do today. I will upload a new set of notes for tomorrow, so make sure you're just working on this section today. Okay, that's all we're going to have. Have a good day, everybody, and as always, stay safe out there.